Welcome to the CS 555 Introduction to Visual Information Processing lecture. As you all know, you have 4 or 5 assignments in this course which will be graphics related. So you will be using MFC SDK or Unix based visual processing assignments. So you have an option of either programming it in Windows, which will be done through MFC, which is VC++, or you can do it in Unix, and I'll go through the templates today. I'm the TA for the course. So first let's go to Windows program, which is MFC. In Windows, the Windows general programming model is the way you see it on the board. Usually whenever you open up an application, there are messages sent from the OS to the applications on every action that you perform. So let's say you resize the window, then a message called wm_size is sent to the application through a message queue, and the application retrieves, there is one message queue set up for each application that you run in Windows, and the application picks up the messages from the message queue, and it has to process them to perform the activities to be done. So this is the core Windows programming model. So this is a sample SDK program. Now before MFC, MFC stands for Microsoft Foundation Classes. These classes are used to ease Windows programming. Initially before MFC, there was a coding style called SDK, which is called Software Development Kit. So it is, even MFC is core C programming. SDK was the predecessor, and it was in pure C. But as you go through the code, if you see, this is the initial start of the program. If you know any normal C program, it would start with a void main or an int main. In this, in Windows programming application, usually the entry point is win main, and it has certain parameters. When the application starts, you have to do certain initializations. Then we come on. Then you have to register to the Win class to the Windows, and then you create your first window. So this is the function that you use, which is part of Windows.h, which is used to create a plain window. And then you set certain parameters, and you say that you specify the callback function. This is a callback function. And you specify it when you register the window. So every message that comes for this particular application will be handled in this callback function. So let's say, as the diagram shows, wm_paint is a message from the OS to the application. In this case, we have handled 2 such messages. One of the messages is wm_paint. So now what this does is that it opens up the window in action, and it draws an eclipse on it. The other message is wm_destroy, which comes when an application is to be terminated. So we just perform the action, or rather call the function which quits the program. This is a bit complicated when it comes to very large applications. So if you go sit and code all of this for a very large application, the code will be complicated, and it is just too messy because it's in pure C. So Microsoft decided to come up with MFC, which are wrapper classes around SDK. So the basic MFC idea was to give an object-oriented interface to the Windows programming, such that the code is reusable, and it incorporates OOPS concepts such as reusability. There were certain features that were added, which was an hierarchy. I am sure most of you must be familiar with Java. The base class there, as you know, is object. For MFC, the base class is C object for most of the usage. And it follows a document view architecture. How many of you are aware of model view controller architecture? Is there anyone aware of model view control architecture now. In document view architecture, basically document is the data and view is the portion where you see the graphics. So if you want to change the information being displayed in the view, you would basically change the document and trigger a function view which would modify the view based on the data. This is the hierarchy that was brought about using MFC. If you see, you can't see the picture, right? Anyways, I mean, you wouldn't be using much of it, but anyways, just to give you an overview, the topmost class is called C object, and everything, most of it is derived from C object. I'm sure you're not able to see it, right? But there are some classes which are critical from MFC point of view, which you will be handling. One of them is C Paint DC. In MFC, everything is taken care with the reference of a device context. So if you have a button, it has a device context. If you have a drawing window, it has a device context. I'm just giving you an overview of MFC, but you won't be using this overall. I'll just go over to the part which you will be using for your assignments. All right, there is a very good book by Jeff Probst which is called Programming Windows with MFC, second edition. You probably wouldn't need it because most of the tasks that you will have to perform in your assignments is mostly manipulation of images. There will be, I'll briefly explain what sort of assignments you'll have. The assignments that you'll have will initially deal with loading an image, and then it will be represented in a two-dimensional array, and you'll have to manipulate the data in the array. So MSDN is a very good reference if you have to, I'm not sure how in-depth the coding would be, but MSDN is a very good source if you look forward to learn MFC. And of course there's Google. Okay, let's go over to the, there'll be a template that you'll be using for your assignments. I'll quickly go through the template and explain how the template works, what part of the template that you will be modifying mostly, and then I'll give you some demos related to how the document view architecture works. So this if you go to the course website, this particular link is for the template to be used for Windows, and this is the template that you will use if you are coding in Unix. Both of them are C programming. So let's first see the Windows template. I have already downloaded the template, and this is the template that you will have. It will contain a set of files which most of it will remain same. I'll take you to the part which you will have to modify. All of you, if you are planning to program in MFC, you'll have to install .NET on your machines. I'm not sure if the 555 has a class or a lab set which has .NET machines, but then if not, you'll have to probably install it on the machines that you would be working on your assignment on. I luckily have .NET on my machine, so I'll just give you a demo. When you are going to start an assignment, just copy. I'll just open the file. So what you will do when you start an assignment is open up the zip file and download it, extract it to a location where you want it to. Let's say I've downloaded it on my desktop. Now in here you will see VC++6 workspace. This is the workspace file that you will initially open, and it will load all the project related information. So it will basically load the project, all the files necessary for the assignment. If you come to the class hierarchy, if you come to the Solution Explorer, you'll see the hierarchy of classes that exist. So it has basically three important sections. One is the source file, which is the actual code. One is the header files, which has all the headers, and then there is a resource file, which are the resources being used in the application or your assignment. So the main part that you would be interested in would be the view. As I said earlier, MFC uses document and view architecture. So the class doc has the document structure in it. It might look a bit confusing initially, but then you don't have to deal with all the code that you see. You just have to modify a part of it. For example, this part here, this majorly just this will be the picture, which will, I'll just give you a demo and then come back to the code. So what will happen is that I haven't modified the code at all. When you make any modifications, you have to rebuild the solution. Okay, and then run it. This is the Windows version. This is the MFC version. I'll go on to the Unix version later on. So when you open the application, you can open up an image by clicking on the open button. So you click on the open button and you open up an image. Let's say we open up this image. Don't panic. So this particular window that you see, you can open up as many images as you want. So you can, for each of the window that you open, an object of the document class and the view class will be created, and when you modify the document through the code and update the view, that particular window will be modified. So let's say you click on process. This process is supposed to clear out the window. The code for that has been written when you on the click action. So when I click on, I'll just go through the flow. When you click on the button, a message will be sent by OS to your application, which will say that you have clicked on this button. Your application internally will create an event saying that this particular button was clicked by the user, and this message will be given to your application. The application will execute the function associated to the event. So when I click on process, it just clears out the image. If you load more images, they have a view and a document associated, an object of view and document associated for which each window. So if you open up another, okay. So this is one image. And this is another image. For both of these windows that you see, there are two different objects created both for a dock and a view. When I click on this button and this particular don't panic window is active, the message will be sent to just that particular object, and you will be modifying just this window. When I come over to here and click on process, the application will suggest to the application, the OS will send out a message, and the application will only perform the action on this particular document view pair. As I said, MFC works purely on event-based structure. SDK was message-based, but then MFC came up with the idea of making it event-based. So you can have your own menu for your application. This is the menu that you saw initially when you ran the application process. It didn't, okay. So this was the menu that you saw. If you want to add more items in it, so what you can do is that, and then I can associate an event with it. This lists down all the classes that you have. Now, as you know, your window will be associated to a document and a view. Document is the data part, and view is where you see the window. So you will insert an event for the view. So let's say when I click on this event, I want a particular function of my view class to be executed. So what I'll do is I'll add an event. I'll say in my view, I want on AnyMayur to be the function to be executed when the Mayur button is clicked. So I'll say add an edit. If you see, I am adding a function to the seeking image view class, which is the view class for my window. This is the class for the view of the window. So I am adding a function called on AnyMayur. I'll give you a small demo of how you would be programming. As you can see, from the resource file, we will go on to the event associated with the process button. So the function associated to the click of the process button is on process. So we'll go to the function. Wow. Okay. This is the function associated to the on process click. So when you click on the process button, this particular function is executed. If you go through the function, it is very simple. What it does is that, as I said, with each window there will be a document type associated. So you take from this get document function, you get the document type associated with the particular window, and then you find out the bit per pixel information from the PDoc, from the document type. Then you get the width, the height, and the start of the image related to this particular window. On checking this, you will see that you will get the information that the image that was loaded in the window was an 8-bit per pixel. So which means it was a grayscale image. So you will accordingly perform actions, and when you check and see that it is a 24-bit, it means that 24 bits are used in this particular window or image to represent one particular pixel. In the image, if you have 3 consecutive, let's say you start from the first pixel, the first byte will represent the color. If you are aware, in Windows, if the image is 24-bit, the image, the bit is particularly represented by 3 colors, R, G and B. The first byte in the image, so if it is a 24-bit per pixel image, each bit will be represented by 3 bytes, and the 3 bytes will be 1 byte for blue, 1 byte for green and 1 byte for red. So from offset of 0 you'll get the byte represented by the blue color, I mean the intensity of blue on a scale of 0 to 255, and intensity of green on the scale of 0 to 255 at the offset 1, and at the offset 2 you'll get the intensity level of red between the scale of 0 and 255. For a grayscale image, each byte will represent 1 pixel, which will, and the number associated will be from 0 to 255. I believe 255 is black and 255 is white and 0 is black. And intermediate colors define different levels of grayscale. So for your assignment, you will probably copy this particular portion, which gives you information related to the image that was loaded in the view, and then based on if it was an 8-bit image or a 24-bit image, you will do the processing. Rest all will remain same. I mean, this part you'll probably copy for each of your event, which is loading the image, getting the document object for the associated view, and then getting this information which gives you how much bit per pixel is for the image, or rather each pixel, and the width and the height of the image, and the byte array representing the image. This part is what you'll program. Here, based on the assignment, you'll have to perform computations, which will probably go in here if it is an 8-bit pixel grayscale image, and here if it is a 24-bit image. So what I'll do is that I have brought a small code which performs basic transformation on an image, and I'll show you a demo. As I showed you before, the image, when you load it, and you click on process, so I'm debugging and showing you how the processing is actually taking place. The cursor has now stopped at the first line of the application. So now I'm debugging through. Okay, I got the document type. I have the bit per pixel information, the width, the height, and the byte array representing, byte pointer representing the image or pointing to the image information. So if you see, the height of the image is 320, the width of the image is 512, bit per pixel is 8. So it will probably go into this, which means it was a grayscale image. So this particular code just makes each pixel to 255, which means it just makes the image white. So it will just, for each pixel it will go through the image and make each pixel white. I'll just run it. So here you go, it's all white. And if you open up a colored image, and you click on process, if you see byte per pixel, bit per pixel, it is 24, which means the image is true color 24 bits image. So it will go into the second if. and it will do the same. It will set RGB level for each of the pixel to 0, which means it will basically make each pixel black. So it will go through the all the pixels and make all the R component, B component, the red component, green component, and the blue component as 0, which means black. Here you go. So this was a basic transformation. Now I'll tell you how you would add your own functionality to it. Let's say this is the application and you want to write a small function, a menu maybe here, which will invert the image. So if a color is a pixel is black, you'll make it white. If it is white, you'll make it black. And intermediate, if it is an intermediate color. If it is a grayscale level, so you know it's from 0 to 255, what you'll do is just negate it. I mean subtract it from 255 to get the opposite color. So what you'll need to do is add your own menu. And I'll say invert. So here I'll associate an event on click of this particular menu item. There is no event associated to the particular menu item presently. So if I build it, it will just gray out the particular menu option. It won't let me do anything because there is no function associated to click of that particular menu item. Now I will associate one event, or rather a function, event handler for that particular button click. I'll call it on transformation event, which will come by default. You can use the default name if you want, and it should be in the view. The image information stays in the document and the image display will be in view. So all the handlers that you will have will be in the view object. So I'll click on add and edit. This will bring up this particular function template, and you just have to insert information into this. So what I can do is that I can copy. I know this is the standard that will be used to transform the image loaded, so I'll just copy this particular portion from the previous function, which was on process, which we used to black out the screen, black out the image if it was a true color image, and make it white if it was an 8-bit image. I'll just copy that code. Here, I know this is the function that will be called when the invert button is clicked. So what I'll do here is that I'll make it 255 minus the existing color at that pixel. Even for 24-bit, I'll do the same. I'll make it 255 minus . So I have associated a function to the event of click of the button of the menu item. So now I'll come build it, and then run the application. I'll load an image. Now I have associated this particular function with on the click of the event. So when I click here, the cursor will come to this function and it will execute this function. On executing this function, the image will revert will invert. So if I click on it again, it will come back to the original state. Transformation invert. I'll have two more transformation which will give you a more better idea. Flip. I'll add two more menu items. Flip horizontal. Flip vertical. I have brought this code from home, which is the same structure which we saw for which uses basically this information from the document object and then modifies this based on the functionality that I want. So it basically gets the document type, the object, the image object, and then transform each byte in the object to manipulate the image. So, oh, I forgot one thing. This particular variable gives information about the width. This particular variable will give you information about the height. Now, if you see the image array, it is not a 2D array. It won't say X and Y. So what you will have to do is that my width. So it basically, we don't have board here. Okay. So what it does is that, let's say you have an image which is 100 pixels by 50 pixels. If you want to offset to a particular pixel, what you'll have to do is that multiply the number of lines that you want to go to into the width of the image. So let's say the image is 100 pixels by 50 pixels, and if you say you go, this particular array points to a single dimensional byte address. So if you want to go to the 100 to the first pixel on the second line, you would point to 101 offset. So you would go through the first line, and the immediate point that would come on the second line is the 101 pixel. Do you get it? Okay. So this is how you would point to within any pixel in the image. So I have brought a code for flipping the image horizontally and flipping the image vertically. It uses the same template. It gets this information from the document type and then just modifies this functionality to flip the or rather to manipulate the image information such that the image is rotated horizontally and vertically. So what I'll do is that I'll go to this particular menu. I'll go to this option. I'll say I want to associate an event handler for this particular function. This function name will come by default. You don't have to modify it. You can use the same. Again, I have to go to the view class and add it because I want it to kick the function in that particular class which is associated to my image. So I'll say add an edit. I have to put in the code for horizontal flipping here. So I take this particular template from here and place it here. This onDraw function will basically refresh the image. So once you modify the byte array, when you call onDraw get DC, it will just modify it will just redraw the image based on the manipulation that you made on the image object. So I'll write the code to redraw it, and in between where I have to modify the image in these two ifs, I'll paste in the function that I brought. It has the same structure, but it does some does the horizontal and vertical flip operations. So I just put in the horizontal flip functionality. I'll put in vertical flip functionality, add event handler. I'll keep this as it is. I'll go to the view type and add the function. So the adding of the function is done automatically by MFC. It adds this particular, if you all are familiar with C programming, or rather C++ programming, you will have an header file and a CPP file, and you have to write the function signature in this header file, and then write the body for the function in the CPP file. So adding the function to the header file is done by MFC itself, or the Visual C++ GUI itself. So if you go here, see, these three functions were added by the VC++ editor directly into the class that was required, and this function came by itself. So I copy these two functionalities here, and I copy the initial part, and in between I'll put in the functionality for vertical flip. Transformation invert, this was the original functionality we put in. Flip horizontally, oh, I skipped the code, I mean inverted the logic. So this basically is a transformation to manipulate the code, the date information in the array of so it just manipulates the byte information in the image, and when you redraw it, the transformation are displayed on the screen. So if you do MFC, if you stick to MFC, this is the template you will have to follow. For every assignment, you will have to download the WAR file, the zip file, and then extract it to a folder, and then add in menu items, and with each menu item you will have to associate a function which will be in the view class, and then write the body for it, and the body will basically go in here if the processing is being taken place for an 8-bit image, and in this if it is being processed for a 24-bit image. So this was the Windows part. Anybody has any doubts? All right. Who all are interested in coding in MFC or Unix? Anybody has any particular inclination? No. Okay. Most of it, as far as I remember, most of them just used MFC last time. No one went for the Unix option, but you have it at your disposal. Yeah.
In the 24-bit image, we are multiplying the I into width by 3. So
So basically, I'll just go over to the code, which will give you a clear idea. Yeah, so for 8-bit, as I said, if it is an 8-bit per pixel image, then each pixel will be represented by just 1 byte, and the level will be for 0 to 255. On the number that you put for each pixel, it will show the appropriate gray level. Okay, for a 24-bit pixel image, each pixel will be represented by 3 bytes, which will be 3 different red, blue and green levels, which will determine the final color. So if you see here, I is the height. So what I do is that, can I get the screen up? Oh, is there a chalk? Oh, yeah. So if you see, let's say this is your screen, or rather this is your image. And the x coordinate will start from 0, 0. So it will be, this will be the first byte, this will be second, third, fourth, fifth, sixth, and so on. Let's say the last one is 100. So this is just the pixel representation. For an 8-bit image, each pixel will be 1 pixel, or sorry, each 1 byte will represent 1 pixel. Whereas for a 24-bit image, 3 bytes, which will be 3 consecutive bytes, R, G, and B, 3 bytes, will represent one particular pixel. So each pixel is made up of 3 bytes. This will give you an idea of why it says I into I width. So let's, in this case, the I width is equal to 100, and let's say the height is equal to 50. So I height is equal to 50. So let's say I want to, so here it will be 0, 1, 2, 3, 4, and so on till 50. So if I want to go to the pixel, let's say 0 and 1, 0, 1, this will represent to pixel number. The pixel, as I said, it's an are represented in the image as a byte array. So let's say, first I'll explain for an 8-bit image, and then I'll go on for the 24-bit image. So for an 8-bit image, this byte, which is at the offset 0, so the byte will be in this order. The byte stream will point to the image in this order. This will be the first byte, second byte, third byte, fourth byte, up to 100 byte, and this is the 101th byte, so on and so forth. This is the 200. This one is 201 to 300, 301 to 400. So if I want to go to this particular byte or this particular pixel, it will be represented by byte number 101. All right. It's the 101th byte, but it is 0, 1 pixel. If this was to be a 24-bit image, each pixel would be represented by 3 bytes. So if you want to go to the first, so this particular pixel, which is 0, 1, will be represented by 3 pixel. So the start of this byte will be 0, and since there are 100 pixels in the first row, the number of bytes it will take is 300 bytes, because it's 3 pixel per byte, 3 bytes per pixel. So if you want to go to this particular pixel, it will be 301st pixel, will be the first pixel for the second row. This is how the computation is taking place here. So I is the, this says int I is equal to 0, I less than height. So it will say I is equal to 0, I less than 50, I plus plus, then j is equal to 0, 0, j less than I width, j plus plus, which means it goes from 0 to 100, or not, rather 100, it will go from 0 to 99. And this is how it will compute. I into I width will take you to the first character of that line, into 3, represents that it was a 24-bit pixels, which 24-bit image, yeah, rather. So into 3 means that there were 3 bytes representing each pixel, so we are going to the first pixel of the ith line, and then j into 3 will give you the offset of that particular pixel. Are there any more doubts? So basically, for your assignments, you will have to manipulate this array. There will be logic given to you for what is to be done, and you'll just have to manipulate the array and then keep the rest of the logic as it is. So if you keep this information as it is, oh, you don't see it, right? Excuse me, could you get the screen down? Okay, so if you go to this particular line, these will remain same, the initial part. The last part of drawing the image back on the screen will remain same. This will be the part that will remain and that will modify based on what image you have. So if you modify code, if you are putting in logic for 8-bit image, you'll have to write the logic in this if, and if you're manipulating an image which is 24-bit, you'll have to write the logic in this particular if loop. Are there any more doubts? Alright, this was the MFC version of it, and now for those who are interested, I'll show you a demo of the Unix version. For the Unix version, you'll have to code on the Bingsons. If you go back to the site, this is the link that will take and that will get you the template of a Unix programming version. So basically, these are the even this is not required. Okay, these are the 3 main files that you will require. Makefile. How many of you are aware of Makefile? All right. How many of you are aware of Ant? All right. Makefile is basically a build tool. You wouldn't have to modify this file, but I'll just explain you what Makefile is. Oh, this is complicated again. This basically, if you are going to submit a code, or maybe in production when you are going to give a particular application to a client, in that case you wouldn't expect the person opposite to build all the file manually and then run the application or whatever, make the jar file. You don't want that to be a manual process. So what you do is you make a Makefile, and this has the rules set in it, which will carry out tasks in an order, which will do all the compilation and the building tasks automatically. You don't have to care for, you don't have to worry for this particular assignment or this particular application. In this, you just have to modify the sample.c, which has the logic for the assignment. So what this particular C program does, this is a Unix-based assignment, Unix-based code. So what this does is that it has an input file, which is the input.tif which is an image file, and it gives an output to an output.tif. Your assignments will be dealing with images. With MFC, you have a GUI where you load an image and then process it when you see it. With Unix, you don't have that much control. So what this particular application will do is that it will take an image, then you have to write your logic for manipulating the image, and then it will dump to the output.tif. Input.tif is an image file, output.tif is an image file. You don't have to worry about the logic of reading from that file or writing to that file. That logic is already implemented. Your task will be just to manipulate the image once it's loaded. So this read.tif file will basically open the input.tif image, and then the input, this particular function void read.tif is written in such a way that it opens the input.tif file. It populates these particular global variables with the appropriate information. In the int32 pixels image, which is a normal int of 32 bits, it will store how many pixels are there in this image. The second one, the second variable, which is calls, that will represent how many columns are there in that particular image. The rows will specify the rows, and the array of 600 and 600 will represent the image. This all task of loading the image and storing the information in this particular global data will be done by this particular function, and the write.tif will use the modified data and write the information back into the output.tif. So your tasks lies in between here. Presently the application, what it is doing here is that the manipulation being done on this image presently is it is clearing the image in between. So if given an image, what it will go do is that it will go through 1/3 of the image, leave the image as it is, go through the second 1/3 of the image, clear it out, and leave the third part as it is. So it will just clear out the logic in between. This is what it does. There is a local variable temp1 which will calculate the number of pixels by 3. It will keep the output data as it is for the image. For the next 1/3, it will write FFFF, which represents white, and then it will keep the last 1/3 as it is, and it will output to the file. This is how the write.tif works. So this is the Unix version of it. For those who are interested, you will have to write your logic in between here. So you have to manipulate the data array based on the input array. This particular part is which will be loaded with all the information. You will have to just manipulate the input information and output it to the data array in between here. Not here, just this part. Now I'll just run the application and I'll tell you how to run the code. I have already uploaded it to my own instance. So as I said, makefile is a utility to build the application. To run the makefile, you have to write in the command make. It uses the makefile. It reads through the makefile and sees what all tasks it has to perform to compile the project. So when I say make, it will compile through all the files necessary and it will output a file called sample. This is the executable that will take in the input.tif file and output the output.tif file, and based on the logic that you've written, it will make the necessary transformations. So when I say, let's say I'll remove the output.tif, and I say make is update. So I say dot sample. It went into the logic and it performed this particular operation. It opened the file, it outputted 1/3 of the image, initial 1/3 of the image as it is. It cleared out second 1/3 of the image. It made it all white, and the third part it kept as it is. So if you see, this was the output that I had taken earlier. So it basically kept the first half as it is. It wiped out the second half, and the third half it has kept as it is. Most of the students last time used MFC for their assignments. Though for those who are interested in doing it in Unix, you are always welcome. Are there any questions so far? Okay. If you decide to program in MFC, when you compile, this was the folder. Let's see. When I build a solution in VC++, a folder is created called debug. This has a lot of files which are not necessary when you submit the code, so you should delete the debug folder. This unnecessarily increases the assignment size, so you just delete the debug folder, and then you will have to zip this particular top level folder and upload it through the digital Dropbox in Blackboard. Are you all aware about Blackboard? Who here is not aware of Blackboard? About the digital Dropbox? Alright, great. For the Engineer students, I'll just show you how the Dropbox works. If you go to blackboard.binghamton.edu and you log into it, when you go on to the, I'll go to Phone of Fine. When you click on the course, you will see course tools, and you see digital Dropbox here. You'll have to use this digital Dropbox to submit your assignments. It probably wouldn't work for me because I'm TA, but I'll show you through a subject that I have enrolled for. So if you go to your course and you go to tools and you go to digital Dropbox, it will give you this particular option. You have to add a file. So what I'll do is that I'll go to my assignment, I'll delete the debug folder, and then I'll zip the application. So I have my zip folder, zip file ready. I'll give it some name, maybe VIP assignment number 1, and I will select the file to be uploaded, maybe give it some comment and then say submit. Oh, I wouldn't submit because it will go to my professor, but you will have to submit it and send it to online through the digital Dropbox. Keep in mind that your timestamp will be recorded on the digital Dropbox, so your late marks will be calculated accordingly. Yes?
If you just add the file, it doesn't go to the professor. You gotta actually
Send it.
Send
yeah.
it. But you can do 2 for 1 if you hit send. It'll
Oh
do
yeah,
both.
yeah. But I mean, this is how you will have to submit your assignments, and it will come to me and Professor Yin, and we'll grade the assignments accordingly. The digital Dropbox keeps tracks of when you submit the assignments, so submit it before the deadline, otherwise the ranking scheme will kick in. That's for the digital Dropbox. Alright, for those who don't have .NET installed on their machine, they can download .NET from the Watson School website. Watson School have the provision of downloading .NET from the college website, so you can go to this particular link. I have the link on the slide, so you can later on go visit the link and download .NET if you don't have it. You just have to go to this particular page and then click on login, which will take you to this page, and then you click on I've forgotten my password, and then type in your email address. It will send you your password online, and it will also give you the link from where you can download it. So you just log into the site and download .NET, and it will install it automatically on your machine if you intend to do it in MFC. If you do intend to do it in Unix, you'll have to do it in Bingson. Bingson is set up for the Unix assignments. You don't have to install anything. That's all. I mean, you have to remove the debug folder, install .NET if you don't have from the link. If there are images that are too huge in the assignment folder, you should better delete them. For example, if you see any 2.bmp, it's a very huge file. I'll be having it, so no need of sending it again. It will just increase the size of the WAR file that you send. Submit using a Dropbox. You will probably have to submit a README. The template for this will be provided to you. I guess that's it. Do you have any questions? Yeah.
So all the image I.O. is done for, you don't have to write like a bitmap loader or anything like that?
It has all been taken care of. If you decide to do it in Windows, you just have to modify the part which is in the if block. If you do it for an 8-bit image, you have to modify or rather write your own code in the if block of the 8-bit pixel. And if you do it for a 24 one, you'll have to write the code in the 24-bit pixel block.
So we only have to deal with 8 and 24, we don't have to deal with...
No, that's it. I mean, you just have to manipulate 8 bits and 24 bits. Actually, the logic is what will matter more. If you are not able to do it for a 24-bit, you can just do it for an 8-bit. That should be fine, I don't know. The logic is main part. Are there any more questions? I guess then we are done for the day. Thank you.